everyone, my name is Yuan Xiang, upcoming senior in electrical engineering. This summer I've been working with Professor Najafi, Dr. Becky Peterson, and James McCullough on a bridge harvester project. Bridges and infrastructures are gradually deteriorating, so wireless sensors have been put on bridges to monitor their health. One way to power these sensors is to harvest the energy from the bridge vibration instead of constantly changing batteries, which will be costly and difficult to do. Here's a picture of a harvester underneath a bridge. In the center of the harvester is the inertial mass. It's suspended by a spring structure on top and bottom. As the bridge vibrates, the inertial mass will be vibrating together with the bridge. On top and bottom of the inertial mass is a frequency increase generator, or FIG. It has a latching magnet in the middle suspended by a spring. When the inertial mass comes close, the magnet will be latched to the mass. As the mass pulls away, it will be oscillating at its resonance frequency, which is much higher than the input frequency. Behind the spring is a generation magnet surrounded by coils, and will be harvesting the induced voltage through these red wires. This is what the harvester looks like as a whole, and here is a shaker table where we'll be testing the harvester and collecting power data. Now let's mount the harvester onto the shaker table and see how it works. It's shaking. Now let's check out what we're getting on the oscilloscope. This is the induced voltage from the two generators. It's looking good. I've been collecting data from the shaker table on the different frequencies, accelerations, and configurations. Here is a plot of power versus frequency at an acceleration of 1/10 of gravity. I've produced many other plots like this over the summer. Besides collecting data, I've also worked on a MATLAB program. It models the movement of the inertial mass and two figs. You're looking at the Simulink models that simulate the system under different cases. I've been debugging and making improvements to the original program by Zeno Galchev. This is what the output looks like. It shows the movement of the inertial mass in the middle and the movement of the figs on top and bottom. That's what I've done this summer. Finally, I'd like to thank Professor Najafi, Becky, and James, who have been very helpful throughout the summer, and for NIST for funding this project, and for Shure for giving me this precious opportunity. It's been a great summer, and I've learned a lot from it.